All right, so note 0.1, we're going to identify representations. So we're going to be able to tell if it's arithmetic or geometric, if it's got a common difference or a common ratio, and the start times, and then be able to find the next three numbers. Okay, so I really recommend colored pencils today. So if you need to borrow some, there's some at the front of my table. So the first example is already done for this. This one is an arithmetic sequence because as we go down our table, we have minusing by 3. So if it's arithmetic, that means we have a common difference with the D, and that difference is minusing by 3, okay? Our start time, so what a start time is you look at what number you start with on the X side. So we are starting with -1. That's our start time, okay? So it won't always just be time 0 or time 1. It can be time -1 as well. Then we talk about what's our start number. Well, our start number is the f of x value. We started with -5, which is what we start with on the f of x side of the table. And then what we would do is we would find the next three numbers. And my printer printed badly. So if we're minusing by 3, -14 minus 3 gives us a -17. And then -17 minus 3 is -20. -20 minus 3 is a -23. Okay, let's look at the next one. So here, this time, we have an image. All right, so the image already states that we are starting at the beginning. So at the beginning, using our time phrases here, which time are we starting with? We're starting with time 0, right? At the beginning is a time 0 phrase. All right, now let's figure out what's happening here. So we have 3 dots, then we have 2, 4, 6 dots, then we have 4, 8, 12 dots. So we have a start number of 3. And then what are we doing? How do we get from 3 to 6? That's the same as 6 to 12. Well, that means we are multiplying by 2 as we go down our table. So we have a common ratio of times 2. And if we have a common ratio and we're multiplying by 2, that means we have a geometric sequence. And I'm abbreviating that, geo. So the next three numbers, after 12, 12 times 2 would be 24. 24 times 2 would be 48. 48 times 2 would be 96. All right, now this time we have a list. In number 3, we have a little love note. We have a list of numbers. Lists always start at time 1 because this is our first number. This one is our second number. Then we have the third and then the fourth and the fifth. So that's why in a list, this is your first number, which is why it starts at time 1. Okay? Starts at time 1 because 26 is my first number. And I just kind of said it here. The number we start with is 26, right? 26 is our start number. So our start time is 1 because this is our first number. And our start number is 26 because that is the first number in our list. Yeah, all right. So now we're trying to figure out what is happening as we go down the table. So we go from 26 to 20, then 20 to 14, 14 to 8, 8 to 2. Okay, so we're either, if we're getting less, so we're either dividing or we are subtracting. But since my numbers aren't getting small really quickly, we're probably subtracting, and we are subtracting by 6 in this case. So that means we have a common difference of subtracting by 6. And if we have a common difference, if we're subtracting by something, then our sequence is arithmetic. So our next three numbers, 2 minus 6 is -4. -4 minus 6 is -10. -10 minus 6 is -16. All right, next up here, we have a word problem. So Miss R has 240 stickers at the beginning of the school year. She hopes for every quiz or test, she loses half of them. So what does what's the start time here? What phrase gives us our start time here? At the beginning. So that's time 0. And then you got to ask yourself, what's the start number? How many stickers is Miss Rawolf starting with? She's starting with 240 stickers. What is happening as she goes through quizzes or tests? What does she hope is happening? She hopes she loses half of them. So if half is a common ratio word, so we're multiplying by 1/2. And if it's a common ratio, that means the sequence is geometric. So if she starts with 240 and loses half of them, our next number is 120. Then half of 120 is 60. Half of 60 is 30, and so on and so forth. All right, the next one here, the last one I'm doing on the video is a graph, okay? So I can already tell what the sequence is gonna be based on how the graph looks, right? Because our options were either a straight line or a curved line from our definitions. This is actually a curved line, so that means it's a geometric sequence, and I know it's gonna have a common ratio. I don't know what it is yet, but I'm gonna figure it out. So whenever you have a graph, what you wanna do is you wanna write a table of your points from, that's supposed to say from the graph. All right, so let's look at our first point here, because remember, we read graphs from left to right. So starting at my left point, the x value is 1, the y value is 16. Next point, the x value is 2, and the y value is 8. So we have 2, 8. The x value is 3, the y value is 4. Then we have the x value is 4, the y value is 2. And then we have the last one here, we have the x value is 5, the y value is 1. All right, so we start at 16 and we're going down, we're getting less, so we are either subtracting or dividing. So let's see. We are dividing by 2, but remember, we can't say dividing by 2. Instead, we have to say multiplying by 1/2. So as we are going down our table here, we are multiplying by 1/2. So that means our common ratio is 1/2. Now let's look at this. Our start time is what? What did we start with? What's our x value? What are we starting with? Start time here is a 1. What is our starting number? 16, that's what's on the other side. What would be the next 3 numbers? Why don't you figure that out? So we should get 1/2, then 1/4, then 1/8. All right, that's the end of this video. If you got it, if you're like, okay, I get what's happening here, then go ahead to your exit ticket and start on your homework. If you're like, ooh, I need a little bit more help, then I will help you with the reverse side of problems.